At sunrise, one of the world's largest nuclear construction projects begins to reveal its extraordinary scale, designed to deliver reliable electricity for generations to come. Every section of this vast site has been carefully planned, allowing thousands of specialists to construct multiple critical facilities at the same time. Before construction begins, survey teams measure every meter of land to establish precise reference points for the structures that will soon rise here. Advanced surveying technology converts the landscape into highly accurate digital models, ensuring every foundation begins with exact measurements. Geological investigations reveal the hidden strength of the ground, providing essential data before millions of tons of concrete are placed. Heavy earth-moving equipment reshapes the coastline, creating stable platforms capable of supporting one of the largest engineering projects ever attempted. An uninterrupted flow of excavation and transport steadily transforms uneven terrain into engineered construction zones ready for permanent foundations. Days of continuous excavation compress into moments, revealing the remarkable speed at which modern construction permanently changes the landscape. Gigantic reinforcement cages are carefully positioned to create the structural backbone that will support the immense weight of future reactor buildings. With reinforcement secured, continuous concrete placement begins, forming exceptionally strong foundations engineered to support decades of reliable nuclear power generation. The reactor base slab requires a continuous concrete pour on an unprecedented scale, demanding precise coordination between batching plants, trucks, and pumping systems. Engineers carefully monitor temperature and curing conditions, ensuring the massive foundation achieves the strength required for critical nuclear structures. With the foundation complete, the containment structure begins to rise, creating the protective shell that defines the heart of the nuclear facility. Every joint is welded and inspected with exceptional precision, ensuring the containment building meets the highest engineering standards. Over months of continuous construction, the containment structure evolves into one of the most recognizable and important elements of the power station. The reactor pressure vessel, one of the most critical components in the plant, is carefully prepared for its precise installation. Using laser guidance and constant monitoring, the vessel is aligned within millimeters of its designated position inside the containment structure. Massive steam generators and heat exchangers are installed to transfer thermal energy efficiently throughout the power generation process. Thousands of high-pressure pipe connections are welded, inspected, and documented to ensure long-term reliability under demanding operating conditions. Automated inspection systems verify every internal surface, allowing engineers to confirm that critical systems meet exacting performance requirements before commissioning begins. Inside the turbine hall, one of the plant's largest mechanical components is positioned with extraordinary precision to convert steam into electrical power. Every turbine rotor is measured and inspected to microscopic tolerances, ensuring maximum efficiency once high-pressure steam begins flowing. The generator is carefully assembled around the turbine, forming the system that will ultimately transform mechanical energy into electricity. Large condensers recover steam after it leaves the turbine, allowing water to return efficiently into the continuous operating cycle. Kilometers of heavy electrical cable connect every major system, creating the network that distributes power and operational data throughout the facility. Advanced switchgear provides safe control of enormous electrical loads while protecting both equipment and personnel during every stage of operation. The control room becomes the operational center of the plant, continuously monitoring thousands of instruments across every critical system. Cooling towers rise high above the site, becoming some of the most recognizable structures within the entire nuclear power complex. Specialized marine engineering connects the facility to its cooling water source through carefully constructed offshore intake systems. Initial circulation testing confirms that the cooling infrastructure is ready to support safe and continuous plant operation for decades to come. With construction complete, engineers begin a series of demanding pressure tests to verify the integrity of every critical cooling circuit. Every increase in pressure is carefully monitored, allowing engineers to confirm the strength and stability of the newly installed systems. Inspection robots explore areas beyond human reach, capturing detailed images that verify every weld and internal surface. Thousands of automated valves are tested individually, ensuring every response remains accurate under simulated operating conditions. Digital simulations allow engineers to evaluate plant behavior under countless operating scenarios before electricity is ever produced. Operators rehearse complex procedures repeatedly, preparing for every situation through realistic system simulations and coordinated team responses. Protective shielding is thoroughly inspected to confirm that every structural barrier performs exactly as designed. Independent backup power systems are tested to guarantee essential equipment remains operational under every possible condition. Outside the plant, the transmission network prepares to receive electricity through carefully tested high-voltage infrastructure. Years of engineering, precision, and relentless construction come together as this monumental power station begins supplying reliable electricity to millions of people. Electricity now begins its journey, traveling across vast transmission networks that connect this power station with millions of homes and industries. High-voltage substations regulate and distribute enormous amounts of electrical energy before it enters regional transmission systems. Thousands of digital sensors continuously monitor every critical parameter, allowing operators to supervise plant performance around the clock. Automated inspection technologies continuously evaluate mechanical components, detecting even the smallest changes before they become operational concerns. Routine preventive maintenance keeps every major system operating efficiently, extending equipment life while maintaining maximum reliability. From a distance, the completed facility operates with remarkable precision, its cooling systems working continuously to support stable power generation. Even after completion, a constant logistics network supplies specialized equipment that supports long-term operation and future maintenance. As night falls, the power station continues operating without interruption, providing dependable electricity through every hour of the day. The electricity generated here supports growing cities, modern industries, advanced transportation systems, and the daily lives of millions of people. From concept to completion, this extraordinary engineering achievement stands as a testament to precision, innovation, and the immense effort required to power the future. As each new day begins, thousands of interconnected systems continue working together to provide uninterrupted electricity with remarkable precision. An immense network of sensors continuously measures every operating condition, allowing engineers to respond instantly to changing plant performance. Regular inspections ensure every mechanical system continues operating safely, efficiently, and exactly as engineered. Autonomous inspection robots reduce manual exposure while delivering consistent, highly detailed assessments of critical equipment. Within the turbine hall, mechanical energy is converted into electrical power through continuous, high-efficiency operation. From the generating station, electricity travels across hundreds of kilometers to support homes, hospitals, transportation, and industry. The impact of this facility extends far beyond its perimeter, supporting modern life across vast regions every hour of every day. Built with extraordinary precision, the completed complex represents decades of engineering knowledge brought together on an unprecedented scale. Every structure within this vast development plays a vital role in delivering reliable energy through one of the world's most complex construction achievements. From the first survey marker to full-scale power generation, this remarkable project demonstrates the extraordinary engineering required to build the future. A continuous supply of cooling water enters the plant through carefully engineered intake systems designed for reliable long-term operation. Before entering critical systems, cooling water passes through multiple filtration stages that protect equipment from contamination. Thousands of intelligent instruments continuously regulate flow, pressure, and temperature with exceptional accuracy. Water chemistry is carefully maintained to protect critical components and preserve long-term operating efficiency. High-capacity circulation pumps move vast quantities of cooling water every minute, supporting stable thermal performance. Grid synchronization ensures electricity is delivered smoothly while maintaining stability across the national transmission network. Routine alignment checks minimize vibration and maximize the lifespan of heavy rotating machinery. Thermal monitoring confirms that heat is transferred efficiently through every stage of the plant's cooling process. From above, the completed facility reveals the remarkable coordination of engineering, architecture, and industrial construction. Every structure, system, and connection contributes to a single purpose, delivering dependable electrical power on an extraordinary scale. Even after commissioning, specialized logistics continue supplying critical equipment required for long-term maintenance and future upgrades. Heavy transport systems safely relocate equipment weighing hundreds of tons with remarkable precision across the operating facility. Advanced diagnostic inspections allow engineers to evaluate electrical equipment without interrupting normal plant operation. An intelligent logistics system ensures essential spare components are available whenever scheduled maintenance requires immediate replacement. Each replacement component is inspected, assembled, and verified before entering service inside critical operating systems. Controlled fastening procedures ensure every structural connection delivers consistent strength under demanding operating conditions. Operators regularly train in advanced simulators, preparing for routine operations and rare scenarios within a completely controlled environment. Around the clock, the plant continues operating with carefully coordinated systems maintaining stable performance through every hour. The energy produced here supports expanding cities, advanced manufacturing, transportation networks, and countless essential services across the region. From the first foundation to decades of reliable power generation, this extraordinary achievement reflects the scale, precision, and vision behind one of the world's greatest engineering projects. Before sunrise, a new maintenance shift begins, ensuring every critical system continues operating with uncompromising reliability. Routine inspections combine digital asset management with physical verification to monitor thousands of interconnected components. High-speed monitoring systems detect even microscopic changes, allowing predictive maintenance before performance is affected. Heavy maintenance operations are executed with exceptional precision to minimize downtime while protecting critical equipment. Continuous laboratory analysis helps maintain water quality, protecting vital systems from corrosion and long-term wear. Inspection drones provide rapid access to transmission infrastructure, improving safety while delivering highly detailed visual assessments. Every replacement component receives permanent identification, ensuring complete traceability throughout its operational lifetime. As daylight fades, the facility continues operating steadily, maintaining uninterrupted electricity generation without pause. Across vast distances, the energy produced here powers essential infrastructure that never sleeps. Built through years of planning, engineering, and construction, this remarkable achievement continues delivering dependable energy for generations to come. As a new day begins, the facility continues supplying uninterrupted electricity through thousands of synchronized engineering systems. Automated lubrication systems protect high-speed rotating equipment, reducing wear while extending the service life of critical machinery. Ultrasonic inspections confirm that essential piping continues meeting strict engineering standards throughout years of operation. Routine alignment procedures maintain exceptional efficiency across one of the largest mechanical systems inside the power station. Autonomous inspection platforms continuously monitor electrical infrastructure, helping engineers identify irregularities long before they affect operations. Carefully regulated cooling systems keep high-voltage transformers operating within optimal temperature ranges throughout continuous service. Beyond the station, electricity travels across an extensive transmission network that connects communities over remarkable distances. As millions of lights appear across the landscape, the power station continues operating with quiet consistency through the night. Each carefully engineered structure contributes to a unified system designed for decades of dependable energy production. From an ambitious vision to an operational engineering landmark, this extraordinary project demonstrates the scale and precision required to power the future. Years after construction, the facility continues operating as a precisely coordinated system built for reliable, long-term electricity generation. Continuous monitoring allows engineers to optimize performance while maintaining stable electrical production around the clock. Precision monitoring confirms that high-speed rotating equipment continues performing within extremely narrow engineering tolerances. Routine inspections ensure the transmission infrastructure continues delivering electricity safely and efficiently to the national grid. Advanced logistics systems guarantee that replacement equipment is always available whenever scheduled maintenance is required. Digital engineering tools allow maintenance teams to verify complex assemblies with greater speed and remarkable accuracy. Autonomous aerial inspections provide detailed structural assessments without interrupting normal plant operations. Integrated into its surrounding landscape, the facility quietly supports growing communities and expanding industries far beyond the horizon. Every connected system reflects decades of planning, engineering expertise, and coordinated construction on an extraordinary scale. This remarkable engineering achievement stands as a lasting example of how precision, innovation, and collaboration can power the future for generations. Every sunrise marks another day of continuous operation, supported by thousands of precisely engineered systems working together in perfect coordination. Inside the control center, real-time information allows engineers to oversee every essential process with exceptional accuracy. Constant monitoring provides immediate insight into plant performance, helping maintain reliable operation under every condition. Regular inspections ensure every major component continues operating exactly as designed throughout its service life. From the generating station, electricity begins its long journey across the national grid, connecting communities separated by hundreds of kilometers. An extensive transmission network delivers dependable power to industries, transportation systems, businesses, and millions of homes. As evening arrives, the facility continues operating with the same steady precision that defines every hour of its mission. The impact of this engineering achievement extends far beyond its perimeter, supporting modern life across an entire region. What began as an ambitious construction project has become a lasting foundation for reliable energy and future technological progress. From the first survey stake to decades of dependable operation, this extraordinary project stands as a testament to human engineering, precision, and the enduring pursuit of powering the future.